Every day there is more and more new energy vehicles on our roads and highways. Fully electric and hybrid cars will enter your garage for an AC service sooner or later. Do these cars require a special procedure when it comes to an AC service? What is crucial to remember when making an HVAC system repair on these cars?
No worries at all. Nissens experts can help you, and we are more than happy to make you understand the systems much better.
So Michael, here it is, a fully electric car Hyundai. Let's start with a small introduction. What is special about these cars?
Well, all of them are high voltage systems. Secondly, they use a heat pump to extend your range and make sure that the efficiency of the battery pack is kept efficient. Secondly, there's actually some components in the system that we haven't seen before, sort of solenoid valves, electronic solenoid valves, electric compressor, PDC heater, and so forth. So that has to be taken into consideration when you buy and service one of these vehicles.
All right, and we all know these are refrigerant-based systems, and since there is refrigerant, there is a pressure, which means that some typical failures can occur, starting from leakages, inner contamination, components failures like compressor seizure. Would those failures mean something more dramatic in an electrical car when it happened to a normal AC system?
Yes, it would, because in normal AC system and normal vehicles, we do have an engine that runs on either gasoline or diesel. With this is actually a battery pack that runs the vehicle. So what's important is that it has the right temperature at the battery pack. Without the heat pump system working, you're going to lose efficiency and you're going to deteriorate the lifetime of the battery pack, which is crucial to this vehicle. So that's the first and foremost. The second thing is that from a comfort level, without the heating and cooling, depending on which weather it is outside, you're simply going to lose all of it when there's not enough refrigerant, the compressor breaks down, something is wrong with the system in general. Basically, you will get a notice if something is not working correctly, and you will have to drive to the actual mechanic to get that done and have it serviced.
What about comfort then?
Well, comfort is going to be an issue because if it is extremely warm day or an extremely cold day, depending, the trip to the bakery or grocery store, if it's extremely warm, there's going to be no cooling whatsoever. So it's going to be a very hot trip to the bakery or grocery store if that's where you're going.
Good. Let's take a look at what to focus on when servicing these highly modern, full electrical cars and their heat pump systems. This might, however, not be a complete guidance, but use it as a framework or a specific tip when repairing the car in your garage.
Start with a good preparation to the service. We recommend learning the specific system you're working on and obtaining as much information before you begin your work. System layout info, technical bulletins, and service information issued by the car manufacturer will ease the diagnostics process and enable you to perform it correctly.
The new energy vehicles and their heat pump systems are loops based on refrigerant, which means that you still have changes of the refrigerant temperatures and pressures. And that is why you will be using a standard troubleshooting tools for the initial diagnosis of the systems. A thermometer, pressure gauges are among the specific tools that you normally use for the initial control of the AC loop.
Start the process with determining whether the heat pump system is in an operative condition. Inspect if it is working according to set parameters, generating enough cold or warm air in the cabin. You should get familiar with the number of heating and cooling modes and engage and test them one by one. For any issues, the root causes must be determined. Since we will have to determine a lot of exact parameters, digital thermometer, clamps, and gauges are the most recommended tools. Having them wireless will also ease the process. The system's static pressure check can reveal whether the loop is charged enough with the refrigerant to build the needed parameters for the system to start up and operate with cool and/or warm air delivery. The working pressures test can tell the operator what may potentially be wrong with the system. For example, whether the AC compressor operates properly and is able to build up the necessary pressure, or if there are some flow restrictions present inside the loop. The temperature-based diagnostics of the loop components is another vital test that can be carried out for the heat pump system. Excessive temperatures be linked to severe failures, such as faulty or blocked valves or inner clogs in the heat exchangers. Temperature measure on each side of the solenoid valve can reveal if it is fully closed or blocked. The system cleanness inspection is another initial and highly recommended troubleshooting. Particles, debris, impurities, as well as improper use of additives, such as leak stop, UV dye, can lead to flow restrictions within thin passages of the system and provoke severe consequential failures. Depending on when in the process you will examine the loop tightness, you can apply one of the well-known methods. Start from a thorough visual control of the loop components and especially the couplings. UV dye detection, as well as nitrogen-based check, can also be included, especially after bigger services like components replacement. The onboard diagnostics is necessary to pinpoint possible issues registered by the HVAC system control unit. This may relate to one of the system's many sensors and valves and electrically steered components. You will need an OBD solution that is compatible with the vehicle and capable of detecting the heat pump system. One of the potential problems that may occur in these systems are stuck solenoid valves. The OBC scan will not necessarily reveal if the valve is stuck, for example as slightly open. However, an appropriate electrical test of the valve can lead to some relevant conclusions. The current signal measurement on the valves can be helpful to determine if the valve receives a proper signal or close to open. Using an oscilloscope picture can help to see if and when the valve activates. A standard multimeter can also perform the test. As in any other AC system, a systematic troubleshooting of the compressor should be incorporated in the system diagnostics. Visual and audio check of the AC compressor should be the initial step. Electrical test by means of oscilloscope is also recommended, as it can reveal improper operation of the electrical motor. If the compressor looks intact but does not engage at all, the technician should look for other system errors. For example, erratic input signals like a faulty low-pressure readings or a bad outside temperature sensor may lead to abnormal AC compressor reactions.
The heart of the AC system, the AC compressor, is a high-voltage device and it requires a specific diagnostic procedures. Do not forget to check out our other materials showing how to diagnose high-voltage AC compressors.
Heat pump systems in electric cars require application of a specific refrigerant and the AC compressor lubricant. The operator should therefore make sure that only consumables prescribed by the manufacturer are applied during the service.
So when servicing an AC system or heat pump system, it's very important that you don't have any cross-contamination or debris in the system, meaning that it's very, very important that you have a dedicated AC machine to recover, pull vacuum and charge the refrigerant to the vehicle. Once you have that, it's very important that you are very specific about the oil added to the system, simply because the slightest percentage of wrong oil in the system will actually destroy the compressor and make the system malfunction.
Evacuating and charging these advanced heat pump systems may require a specific OBD procedure. Depending on the vehicle's make and model, you may need to release some of the valves of the loop in order to get it charged or emptied.
Keep in mind, working with a hybrid electric car may require a specific procedure for the AC service unit preparation. For example, initial flushing is mandatory to minimize the risk of lubricant or refrigerant cross-contamination for double refrigerant units.
When working on electric and hybrid vehicles, safety comes first. It's very important when you interfere with the vehicle that you actually switch off the main switch so there's no electricity in the vehicle. If you are performing a normal AC service, you do not have to switch off the power, basically because you're not interfering with the components. You're just measuring low pressure and high pressure and see if it's actually functioning.
Keep in mind, when working with a high voltage car, the use of dedicated procedures and protective wear and tools is strictly obligatory. Only certified specialists may carry out such service works. Remember, the HV system disabling procedure varies between car makes and models. Make sure to retrieve and study the required manufacturer documentation before performing the disconnection operation. When servicing the heat pump system, several service procedures may be similar to conventional vehicles, but remember that hybrid and electric vehicle AC systems operate as thermal management systems. It means that the system has to be fully functional in all seasons, not only for comfort, but also for the proper functioning of other systems, like the motor unit, the power electronics, and the battery pack. A regular and systematic maintenance of the heat pump system is highly recommended for the overall vehicle's vitality. Before performing the repair, always refer to the car manufacturer's system-specific instructions and specifically to the high-voltage safety protocols.